Hello, this is to explain how to use the TVM on the TI calculator in order to calculate annuities. So this will be using every single button, including the payment button on the TVM. So I have my TVM up here on the screen, and I have a few sample problems and some equations to explain how it will work. So let's get into that. So to begin with, we can calculate annuities with the TVM and using the payment button. All right, so the first thing I'd like to hit you with is the full TVM equation using the 5 buttons. So the 5 buttons are here in the calculator. N for number of payments, interest per year, which that really means interest per period, present value, payment, and future value. And they're connected by this equation, the TVM equation, which is the present value plus the payment times the annuity symbol. So I'm assuming that you have learned a little bit about standard actuarial notation for the annuity symbol. It's for number of payments N at interest rate I over Y per period or per payment period, plus the future value. And since that occurs n periods in the future, we discount it by 1 plus the interest rate over 100. So that's converting from 5 to 0.05, for example, in 5%, raised to the negative n power. That discounts the future value n periods in the future. And that whole sum should be equal to 0. So there's a couple things that you should notice about this. First of all, it's all positive signs on this side. So the only way that this equation can be true is if sum of present value, payment, and future value are positive and some are negative. If you enter them all in with all positive, you'll get an error when you try to calculate something, because it'll say, I can't do it. You can't solve a positive number equal to 0. So anyway, so that's worth keeping in mind, that you have to adjust the signs so that you can get a solution. Okay, and the usual pattern of using the TVM is to specify 4 of the 5 variables and then use the compute button right up here, the upper left corner, one of the most important buttons on the TI calculator. Compute for the 5th one, and that'll tell you your answer. Okay, now we can also, if you notice, this has the present value annuity symbol, but if we multiply by 1 plus I to the n, we can cancel this term here and get this form of it. All right, so here's the other form. If we multiply by the growth factor, we get the present value times the interest growth factor to the nth power, plus the payment. And when you multiply by the growth factor, you convert the present value annuity symbol to the accumulated value annuity symbol S. And then at the end, you get plus FV equals 0. So you have to keep that in mind, one or the other of these, to solve what you want. So for instance, if I were solving for a present value annuity symbol, I would use the first form, and I'm likely going to put the future value equal to 0 so that this complicated term at the end drops out. And if I am solving for an accumulated value here, S, I'm going to likely put present value equal to 0 and then solve for future value. And that's how I can use this equation in either of these two forms. These are equivalent equations. One's related to the other just by multiplying by a positive number. Okay, so that's it. So let's do one simple example to get started with. I have to calculate 100 times A angle 8 at 4%. So you can think about the relation to the equation. What am I going to enter these numbers in? And obviously there are 8 payments, so I'm going to put 8. You have to click 8 and then click N. That sets N equal to 8. And the next thing is the interest rate is going to be 4%. So I would click 4 and then I over Y. And just a reminder, when it goes into the formula, it'll be 4 divided by 100 when you add it to 1. So that's the interest rate. And what's the next thing? So this is a present value problem, so I'm not going to enter in present value. I will enter in the payment. The payment is the number outside the annuity symbol, 100. So I'm going to enter in minus 100. I'm entering negative. I hit minus 100. Oh, I have to hit minus now, sorry. And then we put that into the, I have to click the payment button. So there's that right there. And I've cleared the TVM, but if you haven't, you have to make sure that the future value is 0. So if we do that with 0 FV, and now we've done 4 of the variables. If I want the present value, I just hit compute present value, and there it is, 673. Let's go ahead and see if it came out the same. Compute present value, $673.27 rounding. So that's one. What if I want the accumulated value? So let's just do that. So that would be 100 times S angle 84%. Everything's entered in there except for calculating the future value. Now all I have to do is put 0 in for the present value, and then I will be computing the future value, and I get $921.42. So just looking at the notes here, amazingly, that's the same number as I got before. So that's how we get future value. All right, so that's a basic calculation. You can use it just like that to calculate any of these annuity symbols, at least for annuity immediate. Well, a little later we'll explain what to do if you have an annuity due where the payments occur at the beginning of the period. But for now, we'll just do annuities immediate. Okay, there is an alternative with annuities. It takes a little bit more thinking, but we have the cash flow worksheet, and I will enter in how to enter in the cash flow worksheet. So I'm trying to calculate the present value of an annuity with 8 payments of 100. So the present value is going to be at the beginning. We don't have any value there, so you leave CFO alone after clicking into the cash flow worksheet. And then we're going to enter in the first cash payment. We're going to enter in as positive 100. So I click 100. And remember, you have to hit enter to get it in C1. And then we'll go down to the repetition variable, F01. We've used the cash flow worksheet before, and so I'm depending on you knowing something from previous videos in this series. I have to enter in 8 because there are 8 payments. So I enter in 8 like that. And now I have the cash flow of the annuity in the cash flow worksheet, 8 payments of $100. And how do I get the, so let's just write that on the notes. How do I get the present value? Well, that's done with the NPV button right next to CF. So we click NPV. Now I have to enter in the interest rate, which is 4%. And again, you have to hit enter to go into it like that. And then I have to hit the down button. And at that point, I can say compute. It has a little compute reminder here. You have to hit the compute button. And there it is, 673.27. And if I want the future value, I can hit down again, and there it is. And you have to say compute again, and you get 921. So just on the recording this on the notes here, that's it. So that's using the cash flow worksheet to also work out the annuities. And here it's about similar effort, but in several problems, the TVM is a little bit more efficient. It's right out at the open. You don't have to go into the worksheet and all. And but anyway, they're both alternatives, and they're both important to know because different situations may have one is a better solution than the other. All right, so let's go ahead and do a couple problems here. Here's a car loan of $16,866 is repaid by payments of X at the end of the next 36 months. And the nominal interest convertible monthly is 2.7%. Find X rounding up to the next cent. That's the standard practice in car loans. Okay, and we did this one in the class notes, but here I'm just going to go through and show the buttons to carry out this calculation. So the solution, the theoretical solution is 16,866 equals X times A angle 36. Now the interest rate per month, because this said convertible monthly, that means it's an annual rate, and we have to divide by 12 to get the interest rate per month. Okay, so first of all, let me exit the cash flow worksheet, and I'm going to clear the TVM. So I cleared the TVM, and now what do I put in here? So it tells me the present value, and it tells me the number of payments, so I'm going to put in 36N, and I'm going to say 2.7 divided by 12. And you have to hit equals before you enter that, so that turns out to be 0.225, and that we're going to enter into the interest rate. And now the present value we're going to enter in is 16866, and that I'm going to enter in with a negative sign because I'm anticipating that I want the payment, and that'll be positive if the present value. If you go back and look at the TVM and understand the signs, this is the right thing to do. Okay, so let me write down what we've done so far. 36 for N, 2.7 divided by 12 for the interest rate, minus 16,866 for the present value. And I already know that the future value is 0 because I have cleared the TVM, but I'll put it in there, what the heck. And now we're left to compute the payment. So if we compute the payment, and we get 488.25695, and if we're rounding up, so let's just write that on the notes, 489.257, and if we're rounding up, that's going to be 488.26. That's what we would pay every month. Now the trouble is that because we rounded up, we have overpaid the loan. So typically on a car loan, the last payment is adjusted to make things to come out as equal as possible in what you paid at the interest rate you agreed to and the original loan amount. So how do we do that here? We're going to change the payment to rounding up that number. So I'm going to change this to 488.26. And we're going to put that in for payment. So here's what we did. Oh, that's too much. Okay, we put that in as the payment, and now we're going to compute the future value because that's going to tell us how much we overpaid by. So our future value is negative 11 cents. That's how much we overpaid the car loan. So the correct value is going to be that amount subtracted from the payment. So if I just say plus, and then I say, if you want to get the thing that you have in the payment, so recall payment, and then I say equal, and there it is, 488 point, rounding up, that's 15. So the correct final payment is 488.26 minus 0.11, which is 488.15. And in that case, it's as close, it's less than, the amount that we paid with interest is equal to the loan principal less than half a cent. So within approximation approximately right. Anyway, that's how we do a car loan. So let's do another problem. Darla opens an investment account with a deposit today of $1,000. She plans on depositing $100 at the end of each month for the next 5 years. If the fund earns 5% annual effective interest, what will be the balance of Darla's account at the end of 5 years? All right, so there's a couple things going on here. So first of all, there's a large initial deposit, and then there's monthly payments into the account at the end of each month. So the thing is, we're going to enter both of those into the TVM. But the way it works is we can enter the 1,000 as a present value. That's a contribution today. And so that's what we're going to do. If you go back and look at the TVM equation, it'll make sense to put present value equal to 1,000. And then payment will be 100. Except we're going to do both those with negative signs. So, and the other thing going on is it's a monthly payment. We need the monthly interest. So there will be an interest conversion because it says the interest is 5% annual effective interest. And all right, so anyway, so let's go figure all this out. The balance is 1,000. So the 1,000 that you put in, Darla put in today, is going to accumulate 5 years at 5%. So at 1.05 to the fifth. The 100 is an accumulated annuity, S angle 60. 60 is 5 times 12 months. And the interest rate is the monthly interest rate, which in our standard notation is I-12 over 12. Okay, so we have to figure out that monthly interest rate. So let's go ahead and do that. So I-12, you take 1.05 is the growth factor for 1 year. So we would say 1.05 raised to the 112, and then you flip the 12, 1 over 12, and that equals 1.00407. So we're going to subtract 1 from that, and that is the decimal interest rate, 0.00407. But we want an actual percentage, so I'm going to multiply this by 100. And that turns out to be 0.40741. So just to record what we did, we calculated that's 0.4074%, and that's immediately going into the interest rate. Okay, so let's just keep going with this. Now, the 1.05 to the fifth is the same as the monthly growth factor, 1 plus 0.4074% raised to the 60th. 60 months equals 5 years. So that's going to allow us to put the present value in as 1,000 here. So that's what we're going to do. We're going to put 60 months, and we already have the interest rate in there. We're going to put in minus 1,000, so you have to hit the plus minus and put that in for present value, minus 100 for payment, and all that's going to accumulate to the future value, which will be positive. So when we say compute future value, that is 8,057, and rounding, it would be 0.66 cents. Okay, now the thing is, that calculation did all in one swoop the accumulation of the 1,000 at the beginning and the 100 paid at the end of every month. And so you can analyze it part by part. This is the fastest way to do it all in one go. But if I had put 0 in for present value, that would not have counted the 1,000 at the beginning. And if I say compute future value now, I get 67.81. So that's the accumulated value of the $100 payments. And if I had put in 1,000 for the present value, minus, And if I had put in 0 for the payment and then computed the future value, I get 1,276.28. And so that's the accumulation of the $1,000 at the beginning. And so our final answer is that you can check now that the sum of those two is equal to 8,057. So that's how we calculate that. Anyway, those are two simple examples, and that demonstrates various ways of using the TVM to calculate annuities. We can also do calculations where there is a contribution at the beginning at present value, and we showed how to do that. Okay, so I hope that helps you get a little further along on getting skilled at this calculator. All right, and that's it for right now.